and welcome back to my online teaching platform. We are still looking at application of differentiation in relation to small changes. So we have our third problem here and we have to find a solution to it. The question is find the approximate value for the radius of a sphere if its volume is increased by 25 centimeters cube when the radius is increased by 0.04 centimeters. All right. We are to find the approximate value for the radius of a sphere if its volume is increased by 25 centimeters cubed when the radius is also increased by 0.04 centimeters. Take pi to be 3.142. All right. So here we have been given the change that has occurred in the volume because they are saying that the volume is increased by 25 centimeters cube. All right, so the assumption here is that suppose you have your initial volume to be V0 or V0. It means that let's say that first volume is X. All right, so if the volume has been increased by 25 centimeters cube, that means let's say the first volume is X centimeters cube. So if the volume has been increased by 25 centimeters cube, then it means the new volume will be X plus 25 centimeters what cube because it has been increased by 25 centimeters cube. So for you to find the change that has occurred in the volume, which means that you are to find small change in V, it's going to be your V1 minus your V naught, okay, your V1 minus your V0. So we are going to get it as X plus 25, okay, minus X. And this will give us a result of 25. So you can decide to just pick the increment, which is the 25 centimeters cubes, to be the change that has occurred in the volume without using this approach. But I've just used this one to explain why when you pick just the 25, when you pick the 25 without doing this, you get the same answer because that has been the increment. So that has been the change, the small change in the volume. All right. So the small change in the volume is 25 centimeters what cube. All right. Now let us look at the other part when the radius is increased by 0.04. So it means the small change in R is what? 0.04. Okay. And the focus is on the volume of a sphere. So it means we have to state the formula for finding volume of a sphere. So volume of a sphere is equal to 4 divided by 3 pi r cube. All right, so this is the formula that we use to find volume of a sphere. So we are going to differentiate, we are going to determine the change in the volume with respect to the radius. So we have our dv, dr, which is approximately the same. But let's work on this one first. We have it to be 4 pi r squared. And we know that our dv, dr, okay, is approximately the same as small change in V, which is volume. We are dealing with volume now, no more area. We are no more dealing with the area. So our focus is on volume, sorry. Then divided by the small change in what? R, all right? We know our dv dr to be 4 pi r squared equal to the small change in the volume is 25, okay? Then that of the radius is 0.04, Okay, so we divide 25 by 0.04. We are going to get it to be 25 divided by 0.04 will give us 625. All right. So we have 4 pi r squared equal to 625. We are to find the radius. We are to find the radius. But we have been given pi to be 3.142. But pi is equal to 3.142. In this case, you are not be given the initial radius. So the question is, we are to what? Find the approximate value for the radius. So we are to find the value of the radius of the given sphere. That is the initial radius. Okay, so we are to make r the subject. So we have our pi to be 3.14. So we plug in the value of pi, 4 multiplying 3.142, then r squared equal to 625. That is 625. Then what do? We divide through by the coefficient of r squared, and that will give us 4 multiplying 3.142 r squared divided by 4 multiplying 3.142 equal to 625, also divided by the same thing, 4 multiplying 3.142. Correct. So here we are going to get r squared to be equal to the square root. Sorry, we are here to take square root. So r squared to be equal to 625 divided by 4 multiplying. So 4 times 3.142 will give us a result of 12.568. All right. So what do? We can now take square root of both sides. So we take square root of both sides so that we can get the value of r. We have to find the approximate value of the radius, not the approximate value of the square of the radius. So we are just finding the radius. So we take square root of both sides. So square root of 625 divided by 12.568. Okay. And let's use our calculator to verify. So we are going to get a result of 7. So our radius is equal to 7.05. That's in two decimal places. Okay. So we can conclude that the approximate value of the radius will be equal to 7.05 centimeters. Okay. 7.05 centimeters. I think in the first two videos I have omitted the unit. Okay, so you need to bring the unit anytime you have, unless the question is on percentage increase or percentage decrease. That one there will be no unit. Okay, you are going to get your answer in terms of what? Percentage. Okay, so you just bring your percent. That's just the sign. But when it comes to finding the radius, finding the change, the small change in the radius, small change in the area, volume, and those things, you have to attach the unit to the final answer. If it's about just the radius, you know that radius is just about the length. So we just bring, if it's meters, we bring meter. If it's centimeters, we bring it. If it's about area, you know how to go about it. Square unit, good. If it's about volume, cubic unit, in that order. All right. So this becomes the approximate value of the radius of the given sphere, whose radius has been increased by 25 centimeters cube, and the radius, whose volume is increased by 25 centimeters cube, and its radius is also increased by 0.04 centimeters. All right. So thank you for watching. And please do not forget to subscribe to my YouTube channel for more videos. Bye.